So if the 6 is the 2 and the 3 is the 1, well, it's 2 to 3. So what we do is we take the 6, we cut it in half to 3, and we times it by 3. So I should get to 9. And can I get to 9? No, it won't let me click to 9. So you can see I have that one sandwich left over, so I can't get that third sandwich in there because the app doesn't let me. But that's the idea of mole ratios. We run into this all the time. Making sandwiches, making anything, so on and so forth. And hopefully the project that I do later this week will help you guys out. What it's going to look like in chemistry is like this. It's going to give me a number of moles of something, and it's going to ask for moles of something else. So here I have 3.86 moles of potassium. Reacts completely with excess water. You'll see that word excess a lot in there. It's in there for a reason. We'll talk about that in another lesson, weeks ahead of now. How many moles of hydrogen will be produced? So what's happening here is I'm taking potassium and I'm reacting it with water. Now, for the purposes of this reaction, it's easier to tell water as hydrogen hydroxide, because then I can see that it's a single replacement reaction. The potassium is going to replace just one of the hydrogens, not both of them. So I get potassium hydroxide and hydrogen out of it. Potassium is K. Water is H2O. In this case, I'm going to write it HOH because I want to look at it as hydrogen hydroxide. And then the K replaces the H, making KOH, and hydrogen by itself. And we know that our diatomic elements, hydrogen is one of those, so it's H2, it's not just H. We balance the reaction, we get those coefficients that are in front that are so important for our mole ratios that we're going to find. So now I want you guys to do something during these questions, and I want you to say, hey, what do I know? Well, I know the 3.86 moles of potassium because that's what's said directly in the sentence. What don't I know? It says how many moles of hydrogen. So my moles of hydrogen is my unknown. And that's going to tell me what two numbers are important in this balanced equation. It's the 2 in front of the K and the 1 in front of the H. That's how I'm going to get from my known to my unknown. Because 2 turns into 1, I now can figure out mathematically what 3.86 will turn into, in other words. So I'm going to start with 3.86 moles of potassium. I'm going to put it over 1 just so it's in a fraction, because why not? And then I'm going to multiply by the mole ratio, the appropriate one to use here. And so the question really is, what do I put on top and what do I put on bottom? Well, it's simple if you think about it like this. If you think about it like a fence post. So if we have 3.86 moles of potassium, I'm going to put 2 moles of potassium on bottom because I want those moles of potassium to cancel out each other, right? Like hiya, that kind of thing. And then the 1 mole of hydrogen goes on top because that's my unknown. That's what I want to get to, all right? Now you may remember from a ways back that I told you that the 1 always goes in front of mole. This is that exception that I kind of warned you guys about when we talked about that. When you have moles over moles, then I can put in those numbers from the balanced equation. Notice how the 2 moles of K, it was a 2K in the reaction above it. And the 1 mole of hydrogen, it was a 1 in the reaction above it as well. So the math is super simple here. You just grab a calculator, you take 3.86, you multiply it by 1, you divide by 2, and you get the number that pops out. And you cross off the K's so that you end up with moles of hydrogen. And 3.86 times 1 divided by 2 is 1.93. Now, if you think about that a little bit deeper, you'll see, oh, hey, potassium's got a 2 in front of it, hydrogen's got a 1 in front of it, so hydrogen should always be half of potassium. If potassium was 4, hydrogen would be 2, half of it. If potassium is 6, hydrogen would be 3, half of it. If potassium is 3.86, hydrogen is 1.93 because that is half of the potassium. So that mole ratio is always constant here. And not to leave you guys hanging, I do have one final example here that I'll show you. How many moles of aluminum will react with 0.512 moles of hydrochloric acid? Well, we've got to write down the reaction first. We're taking aluminum, we're adding hydrochloric acid. Some of you might want to think of hydrochloric acid as hydrogen chloride here, that's fine. But regardless, you're going to have a single replacement reaction where the aluminum replaces the hydrogen. You get aluminum chloride plus hydrogen. So we have aluminum. We're adding HCl, which is hydrochloric acid. And we're getting aluminum chloride There, notice the 3 on the chlorine because of the charges with aluminum and chlorine, plus 3 and minus 1. And the H2 from hydrogen because it's diatomic. We balance the reaction. This was actually a tough one to balance, so I'm glad I did it for you on this one. But you can do the T-table, you can start putting numbers in front, do everything you have to do. It ends up being 2, 6, 2, 3. And then we have our fence post looming here. Now, how do we fill this out? Well, I got to have my known, which is my 0.512 moles of hydrochloric acid. That's from the equation up there. Then I got to have my unknown, the question mark of aluminum. What's it going to be? It's not going to be 2 like in the reaction, right? Because hydrochloric acid was 6. It's not 0.5. Well, what would it be? Well, if the hydrochloric acid, we're going to circle the mole ratios. Obviously, we're going to use the aluminum and the hydrochloric. Well, if I start with 0.512 moles of hydrogen chloride or hydrochloric acid, then when I put in my mole ratio using those numbers I circled in the equation, I'm going to want hydrochloric acid on the bottom because I want those to cancel out. So I'm going to have the 2 moles of aluminum on top and the 6 moles of hydrochloric acid on the bottom. And so the math here follows straightforward afterward because remember, we're crossing off the moles of hydrochloric acid. So we take the 0.512, we multiply it by 2, we divide by 6, and we get 0.171. And that's essentially it. That's all we're following through and doing. Okay? So I want to keep this out just for a little bit in case you guys are writing down. But keep in mind that I'm always putting whatever I know, that number is also going on the bottom. It gets a 6 because there's a 6 in the equation. And the aluminum is on top because that's my unknown. It gets a 2 because there's a 2 in the equation. I could do all sorts of things. Like I could just change one word in this question. I could change it to hydrogen. And all of a sudden I'll have 3 moles of hydrogen on top. And the only thing that'll change is the number and moles of hydrogen. Or I could give you a number of moles of aluminum chloride first instead of hydrochloric acid. And a couple of numbers rearrange, but essentially it stays the same, right? Whatever you have goes on bottom, whatever is the new one goes on top, and the numbers are filled in with the numbers in the equation, okay? The biggest thing is to not mix up which one goes where. Make sure your known number, the number from the equation, goes first. Like don't put a 2 there, or 6 there, right? Even though it's 6 moles of hydrochloric acid, that 6 is only for the mole ratio. It's only for the fraction afterward. This 1 is unnecessary. I've had some questions about that as well. Okay, but right now, essentially, I mentioned that before. That a long time ago, right? I always said there was 1 next to the unit mole, but it's not anymore. Really, all we have to do now is the worksheet. So to help you guys out, my grades are hiding my worksheet right now. Oh, you know what? I can go here. Oh, but it's better to use this right here because I can actually type. So this is your homework. This is what you'll be looking at, okay? And at any time, you guys can ask me any questions you need. I'm going to pop up the chat on my screen so I can actually see it in case you type something in, all right? But I want to go through this first one with you guys. There are only 5 to do, and I'm giving you guys the rest of today and all of your class time tomorrow to finish through this, okay? You'll notice that the first couple, I balanced the reaction for you. The second couple, you need to balance it yourself and put numbers in there. And then the last one, you need to write the equation yourself. But I gave you lots of hints, FYI, okay? You'll see K here. You'll have to fix it so it says K2O. I did make a little bit of a goof there. I'm sorry, that happens. But the first thing you always have to do is you have to read the question, right? How many moles of potassium will be formed when 1.52 moles of potassium react with oxygen according to the following reaction? The reaction is 4K plus O2 makes 2K2O. So you do need to keep in mind what is your known and what is your unknown. Your known here is the number that's in the sentence, the 1.52 moles of potassium of K. What we don't know is the moles. It says how many moles of potassium oxide. That's K2O. So I go to my handy dandy fence post maker, which is my equation writer. What I'm going to do is I'm basically going to set up a fence post. So I'll use a couple fractions there because it tends to be simple. I can put in that key, and that'll kind of look like a fence post. But on the top left, I'm going to put in 1.52 moles of potassium because that is my known. Then to figure out my unknown, I'm going to put in a mole ratio here in this fraction right here that I'm going back and forth. I know on the bottom is where my moles of K, of my known, is going to go. I know on the top is where my moles of unknown are going to go, and I'm going to have to get fancy here to put in K2O, K2O. Okay. Then there has to be a number that I fill in on the top and a number I fill in on the bottom. And those numbers come from here. Since it's 4K in the reaction, I'm going to put 4 moles of K on the bottom. And since it's 2 moles of K2O in the reaction, I'm going to put it here. And so to figure out my moles of K2O, what I'm going to do is I'm going to take 1.52, times it by 2, and divide it by 4. So I just grab my handy dandy calculator, and I go, hey, 1.52 times 2 divided by 4. Hey, I got the same thing that was already there. What do you know? It's like that's the only thing I've used the calculator for today. But anyway, it's 0.76. 0.76. You might notice that the 1.52 has 3 sig figs. So if you're really playing the chemistry game, you'll put a 0 at the end there, so that's got 3 sig figs as well, because zeros count at the end if there's a decimal, never always if, right? So, but I have the unit already there for you. Moles of K2O, right? Moles of K should cross out. You know? I should get moles of K2O there. But you can go through and you can finish this. I'm actually going to log off and get this video posted as soon as I can. But if you have any further questions, you can ask them right here, or you can always shoot me an email or text to the number that I've shared with you guys. If you ever have problems getting a hold of me, please let me. You just gotta get a hold of me somehow. I'm constantly checking everything. It's all I'm doing all day. So let me know what's going on. All right. Let's see if I can. Where's my